2 innocent rabbits. Released into a paradise, they will trigger an absolute environmental doomsday. This is not a myth. It is the terrifying mathematical reality of exponential biology. To understand how incredibly fragile our world truly is, let's run a controlled ecological simulation. We will take just these 2 healthy rabbits, one male, one female, and drop them into a massive, completely isolated, lush green grassland. We will grant them a utopian paradise, an infinite supply of fresh grass, perfect weather, and absolutely zero predators. No wolves, no foxes, no hawks, and no eagles. Just pure, undisturbed freedom. And we will let our simulation clock run for 10 full years. To understand the chaos that is about to unfold, we must first look at peer-reviewed ecological data. A single female rabbit can produce up to 7 litters of offspring every single year, with each litter containing up to 6 babies. Even crazier, those newborn babies will reach breeding maturity and start reproducing themselves in just 3 to 4 months. This isn't just a hypothetical thought experiment. In 1859, a wealthy settler in Australia released just 24 wild rabbits on his property for hunting. Within a few decades, that single, seemingly harmless choice triggered one of the worst environmental disasters in human history. So, let's start our simulation clock. What actually happens to our paradise? In the beginning, the grassland is a peaceful Eden. Our initial pair of rabbits lives a life of absolute luxury. They eat, they sleep, and they do exactly what biology commands them to do. By the end of the first year, after a few rounds of breeding and their children growing up to start their own families, our population of 2 has quietly grown to around 100 rabbits. To the naked eye, the grassland still looks perfectly healthy, green, and untouched. Now, exponential growth begins to flex its muscles. We no longer have just one breeding pair. We have dozens of them operating simultaneously. By month 24, the population passes 1,000. The rabbits begin forming underground networks, digging thousands of complex burrows called warrens. If you look closely at the landscape, small patches of bare dirt are starting to appear where the grass has been stepped on and eaten away. But resources are still abundant. This is where the equilibrium shatters. The math turns aggressive. 1,000 rabbits quickly multiply into nearly 10,000%. The once quiet meadow is now constantly buzzing with movement. The rabbits have to travel further away from their home burrows just to find blades of grass. The edges of the grassland are starting to look thin, but the true danger is still hidden underground. The population hits 50,000. The infinite food supply is no longer infinite. The grass simply cannot grow back fast enough to keep up with 50,000 hungry mouths chewing 24 hours a day. The lush green paradise has officially turned into a patchy yellow-brown field. The simulation reaches its critical tipping point. 100,000 rabbits. Every square meter of the grassland is now overcrowded. The green grass is completely gone, chewed down to the very roots. Starvation sets in. Driven by sheer desperation, the rabbits begin eating things they usually avoid. They strip the bark off the acacia trees and dig up the soil to eat the roots of plants, killing the vegetation permanently. The total loss of vegetation triggers a devastating geological chain reaction. Without grass roots to hold the soil together, the earth becomes loose and unstable. A heavy rainstorm hits the simulation. In a healthy ecosystem, the plants would absorb the water and secure the land. But here, the water washes the topsoil away, causing massive soil erosion. The trees, starved of bark and stable soil, begin to die and fall over. This ecological collapse perfectly mirrors what scientists documented in Australia during the late 19th and 20th centuries. The real-world Australian rabbit population exploded from just 24 individuals to an estimated 600 million. They starved out native species, drove dozens of local birds and marsupials to permanent extinction, and turned millions of acres of fertile agricultural land into a desolate desert. The damage was so severe that the Australian government had to build a literal 1,800-kilometer fence just to try and stop them from spreading. Back in our simulation, the sheer density of our starving rabbit population creates a massive ecological footprint. Even though we set the simulation to have 0 native predators, the sudden abundance of free meat causes apex predators from neighboring regions to breach the borders. Foxes and eagles arrive at the perimeter. It becomes an absolute slaughterhouse. But the predators cannot kill them fast enough. The rabbits are still multiplying faster than they can be eaten. The ecosystem is now entirely broken. The population faces a new crisis, a deadly combination of overcrowding and a horrific spread of wildlife diseases, because the 100,000 rabbits are living in crowded, unsanitary, and starving conditions. A highly contagious biological pathogen sweeps through the burrows. Within months, mortality events occur. Millions of rabbits die, not from predators, but from disease and pure starvation. 1 decade later, the simulation clock stops. We look back at the landscape we started with, the magnificent, lush, green paradise has been completely erased. In its place stands a silent, dusty, windswept desert covered in dead trees and abandoned burrows. The population of rabbits has crashed from hundreds of thousands back down to a few dozen sickly survivors. This 10-year simulation reveals a profound and terrifying law of nature. In the world of ecology, a predator is not an enemy to be feared. It is a vital stabilizing force. Without predators to enforce boundaries, life will blindly multiply until it consumes its own lifeline, destroying itself and everything around it. True freedom, when completely unchecked by natural laws, is not a paradise. It is an evolutionary self-destruct button.